about 5 free response workout problems going on. Okay? So let's go through. We'll talk about multiple choice, then we will look at workout problems. Most of the multiple choice, a lot of the multiple choice involves being able to say something about the intermolecular forces that exist between molecules. Okay? So you have to have more than a passing acquaintance with intermolecular forces. So you look at a molecule and say, oh, that's polar, no hydrogen bonds, dipole, dipole. Okay? Not polar, London dispersion. Hydrogen bonding. Okay? So, first question, they give you some information about some compounds, and they ask you to say which one has the highest boiling point. So, the boiling point is going to be a reflection of what? The stronger the intermolecular forces are, the more energy we get to put in to break them apart, so the higher the boiling point. Okay? They give us a measure here. Did we ever talk about dipole moment? We talk about dipole moment. A molecule, okay, that's a dipole, right, has a positive end and a negative end, right? You know that. And if you put them in a magnetic field. If you have, here are the molecules, negative, positive, negative, positive, negative, right? Positive, negative. The molecules are moving all around. They attract one another, but they're moving all around. If we were to take this and put an electric field or a magnetic field around this, what would happen to the molecules?
Start moving towards
They would move, wouldn't they? So they'd orientate themselves so the negative ends were over here. So this would move around this way, wouldn't it? So the negative end would be towards the positive. This one would move around like this. So they would move around. They would have a moment. Physics, when something moves, it has a moment. So it's moving. They move in response to an external field. Which ones are going to move the most? The more polar they were to begin with, right? The more they're going to move. If they were non-polar molecules, then they wouldn't have much of a dipole moment at all. So dipole moment is just another way of measuring the polarity of molecules. The higher the dipole moment, the more polar the molecule is. I just gave you the answers to that question, basically. But you didn't know what it was. All right? Here's another list of compounds, and we ask you to identify what is the most prominent or most important intermolecular forces are. Remember, everything has London dispersion forces. The intermolecular forces. Some molecules don't have dipoles, which are then determine the properties versus hydrogen bonds. So we give you a list of compounds. So you got to identify whether which one's a polar, which one's non-polar, that's hydrogen bond. Here's another group of compounds, and you have to find the one with the lowest boiling point. The lowest boiling point would be which one? The non-polar one, right? Non-polar. We're looking at molecules, we have to decide whether they're polar or non-polar. So I might want to go back and review, what was the chapter 8 or 9, 1045, which molecules are polar. Remember the bent, lowest polar, linear, non-polar if the atoms are the same, trigonal, planar, non-polar, pyramidal, always polar, tetrahedral, 4 atoms are the same, never polar, trigonal bipyramid, non-polar, but if we start putting different pulling groups off and leaving electron pairs, they become polar. And then finally the octahedral or non-polar. I don't know if it's that complicated, but you just review those to make sure you know. Okay? Here's another 4. Okay? Here's another one for the following molecules is dipole, hydrogen bonding, or London dispersion, the most important force. So it's going to be always one of the 3. Here they give you some compounds, and they ask you to predict the one with the highest heat of vaporization. high heat of vaporization, that means what? Strong or weak forces? Strong, right? Strong because it's heat of vaporization, what was the energy required to vaporize it? So it would be the one that was the strongest intermolecular force. All right, there's a couple of questions relative to heating curve. We looked at that problem we did on quiz 1. We had a heating curve. We went up, over, up. Right, solid to liquid, liquid, solid, liquid to gas, and gas. Remember that? Solid. That should be one. Anyway, to identify what's going on at each point. A couple of questions that ask you what's happening down here, what's happening up there, what's happening up here. Okay? Solid's getting heated up, solid goes to liquid, liquid gets heated up, liquid goes to gas, and then we heat up the gas. You just have to recognize what's going on at each point. It's 2 of them, that's 6 and 7. Okay? Here we look at different types of solids, and you have to pick a particular type of solid from a list of solids. So you should remember what that was. I think there was I know in the book there was a chart. I'm sure, yeah.
Is that referring to the different types of lattices?
Oh, I'm thinking about different types of solids. It could be, what are they, molecular, ionic, covalent networks, metallic. Basically the 4 types of solids.
Molecular, ionic, and what? Molecular, ionic?
Molecular, ionic, metallic, and a covalent network. Like a diamond, they're all connected with covalent bonds. Okay? And here's a question about the solid state. What's holding them together? Okay, you have to describe the intermolecular force, and you have to pick out the type of solid. 10 is a question about the intermolecular forces involved in liquids. So they're not as strong as they were in the solid, but they're much stronger than they would be in gas. Here's another molecule, number 11. We give you a molecule, and you have to pick out the problem that which intermolecular force is most important. What's the predominant intermolecular force? Then we have a question about hydrogen bonding. Anything special about hydrogen bonding? You should know about hydrogen bonding. No, what's the strongest intermolecular force? And as H is attached to O and the rest. Here's some statements about viscosity. And you have to pick out the correct ones as well. That might fall under the you have to pick the A and B correct, and the C correct. One of those things. You remember viscosity is the same thing. Viscosity is a resistance to flow, so the stronger the intermolecular forces holding the molecules together, the slower they're going to move. So again, everything goes back to the intermolecular forces from chapter 13. And then there's a question about, another question about liquids and the forces that exist between the liquid and it's on the surface. 2 different forces that exist between the liquid and between the liquid and whatever, it's in glass. What happens when liquid and glass meet together? Here are some properties of liquids, and you have to pick out the one where the largest intermolecular forces are involved. Which process involves the greatest intermolecular force? Obviously it's one. It's between the liquid, within the liquid, right, is the strongest intermolecular force. Because in order to get the liquid to a gas, you've got to break all of those. So that's where the strongest is. All right, then we move on. Looks like the next chapter. What happens, how do things dissolve? What happens to the solute when things dissolve? Okay. Solid molecules can be surrounded. There's a term for that. There's molecules of the solvent surrounding the molecules of the for the ions, whatever it happens to be at the solute. Remember that? Salvation, eh?
What is it?
Salvation. Salvation. Okay, here's a question about solubility of liquids within liquids, or between liquids. Solubility of liquids. You get two choices there. Here's a question about why something will dissolve or not dissolve based on their structure. Again, we got to go back and look at intermolecular forces. If the intermolecular forces are similar, obviously there's a little rule of thumb that says like dissolves like. So things that are like water will dissolve in water, not a compound. Things that form hydrogen bonds with each other can form hydrogen bonds with water, things like that. Here's a question about the solubility of gases. Unusual about that. There's another question about solubility. Why does one thing dissolve in another? Here we have a question about a saturated solution. What's happening in a saturated solution? Here we give you a solvent and a list of compounds, and you have to decide which one would be the most soluble in that particular solvent. So we're looking for polar versus a non-polar solvent, and then match it up with polar and non-polar molecule. Here are some compounds, and they ask about solubility in water. If the particular one would be more soluble in water. Here's a question about pressure and solubility. How does pressure affect the solubility of things? Here are some questions about liquids and intermolecular forces. You have to pick out the one that's incorrect. Incorrect. Then there's a gimme. Then it's a question of defining either one of the three concentrations: molarity, molality, or mole fraction. It could be any one of those three. What's mole fraction? Moles are soluble, moles are soluble, moles. Molarity is moles per liter of solution. Molality is what moles per kilogram of salt. Then here's a question about how freezing points of solutions differ from freezing points of pure solvents. Here are some compounds, and we ask you to predict the one that will have the greatest effect on the freezing point of water, an aqueous solution, so freezing point of water. Here is a compound, and we ask you to predict what the Van Hoff factor would be for that particular compound. The Van Hoff factor. You can predict that. Then here's a question about colligative properties. Understanding what colligative properties are based on. They're based on what? What are colligative properties based on?
The number of particles.
Number of particles in a particular solution. Okay? Those are the 30 multiple choice. And then we go on to the problems. The first one. All right, suppose we had, again, it's a series of, here we're going to have to explain. Suppose we have a series of compounds. Suppose we had, and we ask you to take these compounds and place them in order. What we actually place them in order? Boiling point could be one. Vapor pressure could be another. What else could it be? Viscosity.